Hello, this is Gary Marr of Glendale Community College. This screencast is from my CS 156 Python 1 students. In this video, I want to talk about some of the concepts that are introduced in Chapter 8. Chapter 8 is all about strings. Everything you want to know about strings and then some. Strings, needless to say, are very important to any kind of programming language, Python being no exception, because we have to be able to process text. What I think I'm going to focus on, though, is instead of covering every little example in the textbook and trying to squeeze it into one video, is I'm going to talk about dot notation with strings, or I'm going to give you my first lecture on class objects. It turns out that the way Python stores text or strings and numbers is as a class object. Now, class object's a little different than just a value. The class object contains data, which is the value of that variable, but also it contains some helper methods which can be used to manipulate that value. So for example, in this case, this particular program is looking at regions of the country. N for north, E for east, S for south, west, or W for west. And it's looking for basically a one-letter value, N, E, S, or W, and it's got a compound Boolean expression. It's got four parts to it, all joined by ands. If each one of these are true, then the entire expression is true. Okay, so it stays inside the loop. So the first Boolean expression says region.upper is not equal to n, not equal to e, not equal to s, not equal to w. And what the dot upper is doing, this is actually a helper member that's a member of all strings that we create. And if we use dot notation, in other words, if we put a dot after the variable name and call out one of these many methods, then we can use it in our Python program. Now, a method is no more than a function that's been associated with a class object. Upper is built into Python. There's a whole bunch more covered in Chapter 8. So what this is going to do for me is it's going to take whatever value I have in region, convert it to uppercase, and then compare it to n. And I think you can get an idea of why that's important. If I have to look for an uppercase n and a lowercase n, well, for all these region values, my compound Boolean expression goes from 4 comparisons to 8. Gets a little bit tedious and a little bit long. So in this case, dot upper parems is a shortcut way for me to convert that value to n and do far fewer comparisons. Okay, that's what's happening here. And you'll see that throughout Chapter 8 with different examples. What I also wanted to talk about was a code pattern that doesn't get a lot of press in the textbook, but which I think is important for you guys to understand. What I've done here is I've got an outside while loop that basically asks me repeatedly for information about a product that needs to be shipped. It's going to ask me what region it's going to, how much it weighs, and how many pieces are in that package. It's going to do this over and over and over again until I finally enter a Q to quit. So it's got an outside loop that uses a sentinel or flag value to control the looping. Within the outside loop, I have 3 other loops which are all associated with data which are input that I need to validate. So for example, for region, if I don't have an N, an E, an S, or a W, okay, it becomes true and it asks me for a valid region. If the region is valid, it'll be a W, an S, an E, or an N, or specifically if it's a W, it'll be, in this case, $3, and if it's anything else, it's a 5. Probably from a design standpoint, there's a better place to put this block of code, but I'm going to leave it there for the time being. Below this, okay, is one more if statement, which essentially does the same comparison in the while loop, and it's checking one more time. Is the value that you entered an S, an N, an E, or a W? And if it's not, print an error message. Now, as I look at this, probably a better way of writing this is, obviously this branch is going to be taken if it's invalid. But if it's valid, this may be a better place for this block of code here, because I really only want to have that cost updated if in fact I have a valid value. So I'm going to make that move right now, and hopefully I don't mess up the indenting too much here. Let me just do this. As we all know, Python is rather finicky about its indents. So let me just go back up and fix this. This is a nested if, so the first if has to be there. Cost looks okay. Since this else is associated with embedded if, it has to be there. This has to be indented, and I think that's probably good to go from a syntax standpoint. Won't know for certain until we try it, because we're going to have to execute all this code to see if any errors. The tab character is invisible, and therefore can be problematic when finding tabbing issues within your source code. Sometimes you have to take it to an outside editor and actually look at the invisible characters to figure out where it went wrong. But let's hope this is right. That's the first validation. So what's going to happen here? This is going to continue to loop until it gets a valid value. And I think you can all see the benefit of that. If I'm filling out a page on Amazon and I make a mistake and hit the wrong key, maybe I hit a letter instead of a number, I don't want my program to crash. I want it to come up with an error message, something like input must be NESW, and let me try again. That's what's happening here. The second while loop is essentially doing the same thing. It's going to loop till it gets a good value, except this time it needs to be greater than 0. And then finally, quantity has to be greater than 0. Both weight and quantity have some other calculations that are taking place. The weight cost, the weight gets multiplied by 75 cents a pound. The skateboard, this is a skateboard company. Each skateboard that's ordered has to be multiplied by $2 to give it a valid amount for shipping. At the end of this outer loop, I'm then going to print some information about the calculations that have taken place. And then I'm going to reset the values for region, skateports, and weight, because when I come down to this last statement, which recaptures flag, if I hit enter and want to put another package out there, it's going to the top of the while loop. Okay, it's going to see that it's still not Q, and it's going to ask me for check to see if I have a valid region code. Well, if I don't reset the value to something which is invalid, like X, then what's going to happen, it's going to have the old value, whatever it was, let's say W, and it's going to fall through like nothing happened. I mean, it's going to take whatever values I put before and use them again. And that's not what I want. So it's important, if you're going to use this technique or this code pattern, that you reset the values at the end. This will continue to loop along its way. I don't actually accumulate anything as much as just print a shipping ticket for every item. But I wanted to show you this. This is a very important pattern to have in the validation of at least console input. And then also what was nice about it is I did have an example in here of how you could use a string object in actually one of its methods to make your code a little cleaner. Hopefully that helps. If you have any questions, let me know. Thank you.